drawn it that way to highlight the extremes. In actuality, there's a relatively small difference between the Earth's closest and furthest points from the Sun. If we draw Earth's orbit with the correct shape, it looks like this. You can see it's actually pretty circular. That's not perfect. So it's not the closeness of the Earth to the Sun that causes the seasons. To see what's actually at work, we have to look at the orbit from the side. In our side view, the Earth is revolving around the Sun in this orbital plane here. It takes 1 year to go through a full orbit, 365 days. Remember, at the same time, Earth is rotating on its axis once every day. The important thing, for the seasons at least, is that the Earth actually isn't straight up and down. It's tilted at an angle of 23.5 degrees. So, when the Earth is on this side of the Sun, the northern hemisphere is angled away from the Sun. The southern hemisphere is angled toward the Sun. When the Earth is revolving around the Sun, it stays tilted in the same position. The axis doesn't wiggle around or anything. It just stays fixed in a certain direction. So when the Earth is over here, the northern hemisphere is angled towards the Sun, and the southern hemisphere is angled away. When a hemisphere is angled towards the Sun's rays hit it directly. That's what's happening in the northern hemisphere here. But when a hemisphere is angled away from the Sun, like the southern hemisphere here, the Sun's rays hit it indirectly.
Okay, so what difference does direct or indirect sunlight make?
Well, there's a huge difference. Let's take a look at a simple experiment. In this experiment, we're going to use a flashlight to simulate the Sun. Say that the flashlight is a particular sunbeam. If it's shining directly, all its energy is concentrated in a certain area. But if the sunbeam is shining indirectly, the area is larger. This means that the same amount of energy is spread out over a larger area. So, in a particular point on the paper, it feels fuller in the indirect sunbeam than in the direct sunbeam. And the more indirect the sunbeam, the larger the area. It's important to note that the amount of energy in the sunbeam is always the same. It's not changing. However, if it's spread out over a larger area, we feel it less. Let's take a look at what this means for the Earth. Here we have a globe that's angled at about 23.5 degrees. It's June, so the northern hemisphere is angled towards the Sun. If we shine the flashlight directly on the northern hemisphere, we see it illuminates a certain area. But when we move the flashlight to shine indirectly on the southern hemisphere, we see that it's illuminating a larger area, just like we talked about. So let's put it all together. When the northern hemisphere is tilted towards the Sun, it's receiving direct sunlight. It feels warmer, which means it's summer there. And the southern hemisphere is receiving indirect sunlight, which means it feels cooler. That's winter. 6 months later, when the Earth is on the other side of the Sun, we have the opposite. It's the southern hemisphere receiving direct sunlight, so it's summer there. And the northern hemisphere is receiving indirect sunlight, so they're having winter. And now you know the reason for the season.
Awesome. So it's not how close the Earth is to the Sun that matters, but instead it's the tilt of the Earth.
Which is also why it's winter in Australia at the same time as it's summer in America.
You got it.
Well, I think this has been the most educational vacation I've ever had.
And there's so much more to talk about. Did you know that the Earth...
I actually think I'm good for now.
Oh, okay.
So, what would you like to do now? Bushwalking?
Alrighty. So, does that make sense?
Yep.
So what did we learn from that video? What did we learn about the seasons? Not cause the seasons.
The tilt of the Earth.
The tilt of the Earth. So that is tilted on 23.5 degree axis. And so what did we learn about? What else did we learn about?
The indirect sunlight.
Yeah. So when Australia, which is in which hemisphere? Southern, is facing, say we use this light as the sun, is facing, maybe that way. Say it's summer in Australia,
It's
getting direct sunlight, and then as we move around,
getting indirect.
it's getting indirect sunlight. So, okay, very good, excellent. All right, now in your textbooks, which is in this piece of paper here, if you go to the 3rd page, we're just going to do a quick investigation. So you can all work together on this one because we've got one Earth. So what we're going to do, so we've got the two skewers in there is the axes, which we did last lesson, and the pins that they're talking about. And what we're going to have a look at is longer days and shorter days, and what season Peru might be in compared to Australia. So instead of having pins, I'll just put little dots where the cities are. So you can use this light as a spotlight instead of using a torch. So use that as the sun. So who wants to have a go at holding the Earth? You can do it. Okay, very good. And so you two, so I have one of you standing at opposite ends. So what we're going to do?
I'll do it then. And then.
Yeah, very good. So, okay. So what I want you to have a look at is if, that's great. So if Australia is in, if it's daytime in Australia, on the daytime in Australia, what's happening at the South Pole? Daytime? Daytime. And what's happening at the North Pole?
Nighttime.
Nighttime. So if you spin it one day, so 12 hours, so 12 hours, yeah? No, that's 24, yeah, 12 hours. So what's happening at the South Pole?
It's daylight.
Still daylight. And what's happening at the North Pole?
Still dark time.
Still dark time, night time. So for certain points of the year, like summer and winter, the South Pole or Antarctica is in constant daylight and the North Pole is in constant darkness. So that is why, because the Earth's tilt. So what would happen if you go to, say, spring or autumn? So that's summer in Australia. Yeah, that's summer in Australia. So now go to winter in Australia.
Winter.
Winter? Yeah.
Yeah,
That's winter in Australia, yeah. Very good. So what's happening in the North Pole there?
Daytime constant.
And in the Antarctic?
It's nighttime constant.
Nighttime. Very good. So if you rotate it so you can see where daylight hits. So the Earth rotates in what direction, do you know? Remember what?
Clockwise.
Anti-clockwise. So it rotates from, so it looks like the sun rises from east to west, but when you rotate it from west to east, so anti-clockwise, yeah, anti-clockwise, you see, no, you just rotate it like it's just one day, yeah, so keep rotating it, so you see the light rises sort of in Melbourne and sets over Perth, so that's the direction of the sun every day, so it looks like it rises in the east and sets in the west, but the Earth's actually moving the other direction. So if it's winter, show me on Earth. It's fancy. If it is winter in LA and 12 o'clock in the daytime.
12 o'clock in the daytime.
Yeah.
Winter in LA. Yep. About that.
Very good. So what time approximately do you think would be in Australia?
Ooh, Australia would have to be 12 o'clock. Or maybe 4 o'clock in the morning.
Yeah, that's pretty good. Well done. Okie dokie, what else is on our activities? Well done, sweet.
What?
The smart as a 7th grader.
Yeah. I don't know about that. Come on.
Okie dokie.
Where next, miss?
Well, you can take a seat. Very good. Do you have any questions at all?
I'm sore.
Okie dokie. I forgot to do the daylight hours. Sorry. So if I hold it. So, say if it's summer in Australia. Summer in Australia. So the daylight hours. Would you have a guess at how many sort of daylight hours are going to be longer or shorter in summer?
Longer.
Longer. Why do you think that is?
Because you got the more of elliptical throw of the sun's
Okay.
rays.
All right. Very good. And if you go into winter,
Shorter.
shorter. Very good. So you can see that from when you rotate the Earth there. And what about, say, this is autumn? What do you think is happening with the seasons there?
It's pretty constant between
Pretty
the
constant?
both.
Between the northern and southern hemisphere? And why is that?
In the equator
Yeah.
line.
So why would that be compared to,
It's more of right angles.
what do you mean right angles?
It's more of a constant sun.
More of a constant sun?
Direct sun, the word I think it was technical, was it?
So is in autumn and in spring, is the Earth tilting towards or away from the sun? So in summer, Australia, the southern hemisphere is tilting towards the sun, and in winter it's tilting away. But in spring and in autumn, is it tilting at all?
Still tilting.
Towards the sun, or just on its axis?
From what point?
From spring here? So is that tilting towards the sun, or is that just
Direct.
even?
It's just even.
It's just even. So, southern hemisphere is tilting towards the sun there, but here it's just even. So it's tilting on its axis still, but it's not tilting towards the sun like that, because it doesn't on the same axis. But yeah, all the way around. Okie dokie. Very good. Now, in your workbooks, I just want you to write down. Actually, I might just go through the multiple choice questions now. You haven't got any pens because you forgot them all.
I've got one.
Alright,
We can share.
very good. So we're just going to do this as, you don't need your pens, it's alright, we're just going to talk about it. So, with the multiple choice questions you got in front of you,
Mm-hmm.
the first one, which of the following best describes the period of one revolution of the Earth? So do you remember from the video they talked about revolutions and rotation of the Earth? So rotation on its axis.
24 hours.
So, read the question again. Which of the following best describes
365.
the period of one revolution?
So D, I think they said.
D.
Quarter?
Very good,
I
Nicolette.
wasn't listening, sorry.
365 and a quarter. So, what happens to that quarter of a day? Do you remember?
Leap year.
Leap year. Very good, Christopher. Excellent. So that's why every 4 years we have a leap year to make up for that one day.
Quarter of a day.
Quarter of a day, yeah. 1 day over 4 years. Correct, Jonathan. Australia experiences summer when it does because at that time the sun is hotter, the Earth is closer
See?
to the sun, the northern hemisphere is tilted toward the sun, the southern hemisphere is tilted
D.
toward the sun. D, very good. Very good. Alright, which of the following best describes the reason why it's hotter in Melbourne in summertime than in winter? The sun is further to the north in the sky at midday, the Earth is closer to the sun's more directly overhead and it shines for longer in summer than in winter, or the sun's more directly overhead and it shines for as long as in winter.
C.
See,
Shines longer.
what does everyone else think?
Why is it
Christopher?
in Melbourne?
Jonathan?
A.
A?
C.
C, very good. So the answer is C. So it doesn't matter how close the Earth is to the sun or how further away it is. So living on Earth we experience daytime and nighttime because the Earth revolves around the sun revolves around the Earth's axis is tilted from the vertical, or the Earth rotates on its axis.
Yeah,
In
rotates on its
daytime.
axis.
Yeah, very good. Daytime and nighttime. Excellent. Does that all make sense?
Yep.
Okay, very good. Now, to carry that on, next lesson we're going to do a lesson on the moon. So, 41% of the moon's surface is never visible to us on Earth. Did you know that? You always see the same side of the
I
moon.
do know that.
You do know that. Very good.
Do you
So
know,
that's why.
Do you know the moon is colonised by aliens as well?
Really? Oh, I didn't know that. Maybe you can research it and show me some evidence of that, Jonathan.
Teaching them.
Very interesting. Okay, so for homework, you would research why we only ever see the same side of the moon. So, why is it that we only see the same side? Okay, shut that Very good. So, you don't have any questions? Christopher, you look busy looking through your textbook. Very good.
I'm right. I've got this.
If you want to look back over your notes in the textbooks from page 85 to 89 in your textbook, so have a look over that chapter if you need to again.
Which one?
That one you've got there. Rightio. And very good. We'll see you next lesson.
Thank you, Miss.
Thanks
Thanks,
very
miss.
much.
Thank you.
Goodbye.
Good lunchtime.
It's recess.
Alright, very good.